goes. So for section 3 here, we're doing adding and subtracting. Now I told you that we did the multiplying and dividing first because it was a little easier. It depends on which way you're looking at it. In some ways, the adding and subtracting is easier because the big issue is just identifying, can I add or subtract? If you can, it's real easy. The trick is knowing when can I add and subtract and when can I not add and subtract. So in order to add and subtract radicals, not only does the index have to match, remember the whether it's a square root or a cube root or a fourth root, that part has to match for multiplying and dividing and for adding and subtracting. So notice again, we've got nth root, nth root, nth root. Those all have to match. But in addition to that, in order to add or subtract, everything inside the radical, that's technically called the radicand, everything inside, all those numbers and variables, everything inside has to match. And so do any variables on the outside. Literally, the only thing that can be different is the coefficient out in front. Everything after that has to be exactly the same. If it's the same, then the adding and subtracting is super easy. So look at letter A right here. I have a cube root of 5 and a square root of 2. I cannot subtract those because they don't match. So focus. I can go ahead then and just write that again. 7 cube root of 5. Let's make this a little bigger. 7 cube root of 5 minus 4 square root of 2. I cannot do anything with that. That is as simple as it gets. Now, if you can simplify the roots themselves, even if they don't combine, still simplify, okay? Simplify it as much as you can. But here, cube root, square root, not even the indexes match. So I can't put those together. The next one, though, x root xy. X root xy. Do they match exactly? So all I have to do then is add 3 plus 4. Hopefully we can all do that. 3 plus 4 makes 7. We'll work on it. Give it your best effort here. 7x root xy. That's my answer. That's all I have to do is add the numbers out in front. And then rewrite it with the exact same x's, root x, y. Essentially what we're doing here is like terms. We're making sure that they match. If they do, you add them together. Next one, I have a fifth root of 3x squared and a fifth root of 3x squared. Those match. My answer is going to be a fifth root of 3x squared. The only question is, how many do I have? -3, 17 minus 20. And you told me you couldn't add. So there you go, -3, fifth root of x, 3x squared. That's my answer. And again, it's just doing the 17 minus 20. So why don't you guys try a couple in the homework? Let's do. Let's go ahead and do. Why don't we just do 1, 2, and 3? Do 1, 2, and 3. I'll put those up here as well. Give you 3 minutes. Should be real quick. Yeah, after one. That one, we will bring the 24. Yeah, and then who is somebody else that asked you for that? Okay, if you want to go also right now, this would be a good time. We'll get there. Oh, no, I didn't mean that. Not asking you to like it, unfortunately. Just need you to try it. Okay. That makes it right. No, I'm not gonna collect it. Things on our folder. Yeah, I know some of the teachers try to come up right away. I want to use some flexibility, like no, things come up where you've got activities like that. So as long as it's done by Monday, that's not what check it out. Okay, you're working on the head.
Yeah.
That 12, you can simplify it first and then see if they combine. It would be a 1. And where you're going to see that adjustment.
Yep.
You're exactly right. We'll go over the adjustment. The videos on there as well. You'll see some of the practice as far as little break there. Hopefully the recording. They shouldn't have taken you long. Where's this class? Oh. There we are. So for number 1, we've got square roots of 5. We should be able to combine those. Alyssa, what did you get for number 1? 12 square root of 5. Is everybody good with that? 10 plus 2. Next set, 9 root 2 plus 5 cube root of 2. Joey, can we combine those? No, so we just rewrite it. 9 root 2 plus 5 cube root of 2. If they simplified on their own, you should simplify them. But they're already done. We don't have to do anything with those. Number 3. Oh, the wrong class. Ednan, can I combine those? What did you get when you did? Yep. -3 square root of 11x. Is everybody okay with those? All right, so then back to the notes. Real quick here, letter D. Letter D has a couple things with it that are a little bit different. First off, they're both cube roots of 24, so I can combine them right now if I want to. The trick is I have 4 here. How many do I have right here?
1.
1. So 4 plus 1 is 5. 5 cube roots of 24. That's actually not my final answer though, because 24 reduces. So I want to take that 24, break it apart. 2 and 12. 2 and 6. 2 and 3. So I have a set of 2s here, 3 2s that can come out. That gets multiplied by the 5 that was already out there. So 5 times 2 is 10. 10 cube root of 3. 10 cube root of 3. I could do this another way too. I could have reduced that 24 at the very beginning. Take out the set of 2s. 2 times 4 would be 8 cube roots of 3. Take out the 2 cube roots of 3. 8 plus 2 also makes 10 cube roots of 3. It doesn't matter whether you simplify them at the beginning or at the end, you'll get the same answer. Does that make sense to everybody?
Yes.
All right. Unfortunately, they're not all going to be quite that easy. Oftentimes, you're going to get something like this. Square root of 18 plus the square root of 8. Right now, I can't combine them, but both of them reduce. So that's what I need to start with. I need to break them apart just like we were doing on Tuesday. 18 is 2 and 9. 9 is 3 and 3. Pair of threes comes out. 3 root 2. The 8 is 4 and 2. 4 is 2 and 2. Pair of twos plus 2 root 1, 2 left over. Now they match. I have 3 root 2s and 2 root 2s. 3 root 2 plus 2 root 2 gets us 5 root 2. So again, you can't decide whether you can combine them or not until they're reduced. If they reduce to the same thing, then you can add or subtract. If they don't, you can't. So letter B, same idea. 16, break that one apart. 4 and 4. So really it's made up of 4 2s. It's a cube root, so I can take a set of 2s out. Right there. That would come out and get multiplied by the 3 that was already there. So there was a 3 out there already. 3 times the 2 that I just took out. Cube root of a 2 left over. Minus 2 cube root. Well, actually, before I write that, let's go ahead and break apart the 81. 81 is 9 and 9, which would be 3, 3, 3, and 3. Set of 3s come out. 2 times 3 is 6. Actually, I should use that in a different color. Again, just to keep track. Set of 3s. Cube root of 3. So this ends up being real similar, right? We get 6 cube root of 2 minus 6 cube root of 3. But those don't match. Does that make sense to everybody? Cube root of 2, cube root of 3. That is my answer then. I cannot go farther than that. I could factor out a 6 if I really wanted to. But this is one where this answer that we have right there is good enough. Does everybody understand how I still had to reduce it? I couldn't tell at the beginning whether they would combine or not. There's going to be one on the homework. There's going to be one on the homework where you can tell right away they don't combine, but they still simplify. You still have to simplify them like that. Does that make sense? Get it as simple as you can. That's your final answer. Let's do one more of those. Actually, do you guys need to see another one of those? Or it would be helpful to see one more? Okay, so this one's 3 pieces. It's exactly the same though. Let's break apart all 3 of them. 250 is 25 and 10. 25 is 5 and 5. 10 is 5 and 2. That's a set of 3 5s. Comes out 5 cube root of 2. Next one, take that 54. Break it apart. Again, if you're not quick with these factor trees, just use a calculator. You're looking at 54. I don't know, maybe 2 goes in. Try it, divide by 2. The calculator will spit out 27. And then just keep going. Well, 2 doesn't go into that, but 3 does. Gets us 9. So we have 1, 2, 3 3s. That comes out. 3 root cube root of 2, the 1, 2 that was left over. And then the 16. Break that one apart. 16 is 4 and 4. 2, 2, 2, 2. Set of 3 2s. Those all come out. Actually, I made that mistake last period. Comes out to 2 cube root of 2. Don't forget that it's a minus sign still. Minus 2 cube root of 2. Let's bring down that 5 cube root of 2 that we had from before. Put it all together. They're all cube roots of 2. So I'm going to combine them. 5 plus 3 is 8. 8 minus 2 would be 6 cube roots of 2. Are we okay there? All right, so go ahead and turn to the homework and let's try 7 and 8. Try 7 and 8 on the homework. If you are wanting to work ahead, the homework that's assigned is 1 through 10 all. You could do all those. I would wait on 12 through 26 for now, but we're doing 12 through 26 even. But for now, try 7 and 8. The one that you got set this Tuesday. Let's go over those two. Good. Go ahead and finish up. If you can, give you another 30 seconds here if you're not quite done. All right, so number 7. It's not here today. First, I need to see if anything reduces. Somebody that is here. Saul, did you have anything that reduces for number 7?
Yeah, I got the 12 2 root 3.
Yep, 2 root 3, because again, 12 is 2 times 2 times 3. Take the 2's out. Got 5 root 3 at the beginning. 5 root 3 plus 2 root 3. So then my final answer. Dom, what's the final answer there? 7 root 3 is perfect. There we go. Number 8. We have a couple things that need to be reduced here. Jocelyn, what you want to take one of those two and talk us through how we would reduce the square root? Sure. You want to just tell us the final answer? 57 root 2. Because here you take the 5 out, gets us 55 root 2. Here, this one, take the 2 out, 2 root 2. I had a few people last period forgetting that you're multiplying that 5 and the 11, right? 5 and 11 would make 55. Add those together, 57 root 2 is perfect. All right, so back to the notes now. Back to the notes. Let's get some variables in here. Let's take a look at number 6. Number 6. Right now, I can't combine these because they don't match, but I'm thinking that both of these are going to reduce. So the 72, let's start with that one, break it apart. You could do 2 and 36. Now, hopefully some of you are starting to figure out, if I have a pair of numbers, even if they reduce more, I could stop right here and take that pair out. Does that make sense? I could break the 6s apart, do 2 and 3 and 2 and 3, take the 2s out, take the 3s out. But it's faster if I just take the 6s out. Does that make sense? Normally we go all the way down, we break it all the way apart. But if you find a pair before that, take that pair out. That would be totally fine. So that 6 comes out and is multiplied by the 6 that was already out in front. So there's this one here, 6 times 6. I have a square root of 2 left over. Right, there's this 2 that didn't have a pair, it stays inside, root 2. X's, I've got x cubed, that's one set of x's that can come out, one x that stays in. And if I clean that up a little bit, 6 times 6 would be 36 x root 2 x. That is now as simple as it'll go. I need to check the other one, see if I get the same thing. So for the other one, root 8x cubed, take that 8, break it apart. Again, you're going to start to get real familiar, hopefully, with some of these. 2 and 2, pair of 2's comes out. I'll use red again like I did before. A pair of 2's comes out, is multiplied by the -4 that was already there. Don't forget that negative on the 4. There is a 2 left over that stays inside, root 2. The x's, could take a set of x's out. One set of x's comes out. One x stays inside. This is going to make -8x root 2x. Does everybody understand that this whole thing needs to match? X root 2x, x root 2x. If they match perfectly, then I can combine these. Okay?
Yeah.
So then 36 minus 8 gets us 28. 28x root 2x. There's my answer. Again, all the variables have to match. Everything inside the root has to match. If it does, then I can add and subtract. Letter E, cube root of 54x to the 4th. I'm going to break apart that 54. 54 is 2 and 27, which would be 3 and 9, which would be 3 and 3. Looking for sets of 3. I have one. 3 3's comes out. The 1 2 stays inside. The x's, I can take one set of x's out. Because again, there's 4. Take one set of 3 out, one's left inside. The next one. Need to do the same thing to the second part and see if they match. 16. Break it apart. Is everybody good? 16 is 4 twos. 1, 2, 3, 4. That means I have one set of 3. Those would come out. I have 1, 2 already on the outside though. So it's going to get multiplied by that. 2 times 2. Cube root. Wait, before I put that, let's go ahead and get space for the x that I know is going to come out. So cube root of the 2 that was left over. I have 4 x's. That means 1 comes out. 1 stays inside. So I now have 2 times 2 is 4 x cube root of 2x. Both of them are x cube root of 2x. When that happens, x cube root of 2x, that's going to be the same thing for my answer. Does everybody understand? It does not change once they match. That combines just a single x cube root of 2x, but I have 3 plus 4 makes 7 of them now. That's my answer. 7x cube root of 2x. I want you all now to try try 18 and 20. 18 does simplify to some extent. Simplify it as much as you can. Number 20 is going to be much more like what we just did. But I want you to do both 18 and 20 right now. Sure. Yeah. Another act out. Sorry, yeah. As far as everything, that's the idea. I don't think that's what they go. Oh, no, sorry. Back up. You didn't take out any numbers. About 3 still have a 3 left over in that square. And still have an X left over. It's not. That makes sense. So I looked at but there's still square. Do some, understand? Perfect. It's the same idea. You're just taking out sets of variables as well. So again, the problem is that we're at the end of this, we're going to be doing multiplication and addition, so it's going to be consistent. But you have to know how to do the multiplication. Because I want to stretch your like an hour. You do, your brain's growing right now. Now is when you want to stretch it. Make those new neural pathways. All right, everybody, let's check those two. See how we did on 18 and 20. Oh, back to the homework. There we go. 18. So a lot of you realized right off, you're looking at 18, you've got a cube root and a square root. They're not going to combine, but we still have to simplify them. The instructions say to simplify. So let's try that. The first one's a cube root. Let's see what we got. I want to know what that first cube root simplifies to. Bianca, were you able to simplify that first cube root? That's okay. So what were you able to take out of the cube root? Okay, so you broke apart the 12, you got a 2 and a 6, 2 and 3. And so do you have any sets of 3? Where? Let me see what you did. Oh, you have an extra 2. So you can't actually take out any 2s, but you did take out x's, right? Okay. So for this one, oh, and it's frozen. You can't see what I'm doing. Let me go ahead and fix that. There we go. So we factored that 12. There are no sets of 3. We can't take anything out, but we can take out a set of x's. So this would become x cube root of 12. And that's as simple as that one gets. Does that make sense to everybody? Yes. Take out a set of x's. 12 stays inside because there's no sets of 3 numbers. How about the other one then? The other one's a square root. Oh, that's the other class. Not here. All right, Leanne, were you able to simplify that square root? What did you get? Okay, so you did the 27, 9, and 3. So take out a set of 3s, and there was already a 4 out there. So what does that end up being on the outside? Yep. 12, take out an x, root 3. We still have one x though left inside, right? Because it was a square root. So 3x. That is my answer for that one. I can't combine anything because they don't match. We're done. Let's try 20. So for 20, we had to reduce it all the way. If you have the answer for the reduced one, you can give it to me. If not, we'll work it out. Kathy, did you manage to reduce that first cube root? What'd you get? Yep, that is exactly right. 2x squared cube root of 5x. Because again, that 40 has a set of 3 2s. Take those out, take out a set of x's, but we were left with a 5 and an x left inside. We had that other x that was already out there. X times x is x squared. Cube root here, let's simplify this one. I'll switch colors here so we can keep track. For this one, that should reduce as well. Not here today. LJ, did you simplify that one? What'd you get?
I got negative 3x squared of
Cube root 5x. Does everybody agree? We were able to take out a set of 3s, take out 2 sets of x's for that one. But that means that the x's match. I have x squared, cube root, 5x for both of them. 2 minus 3. What is my final answer? Davian, what's the final answer there? Yep, negative 1x squared, cube root of 5x. That's perfect. All right, I've got one last thing to show you, and we'll be done with today's lesson. Conjugates are a specific matching set. Conjugates are the exact same 2 terms. It's a binomial, 2 terms. They're exactly the same, but one's got a plus sign in the middle, one's got a minus sign in the middle. Anybody recognize this? You're on the right track. We called it, we did it often with guess and check. There was one particular one, and it had a name that looked like this. The difference of squares. That is a hint here. There is a shortcut to this involving the difference of squares. I want you to start off by multiplying stuff out. If you find the shortcut, you're welcome to use it. If you don't find it, we'll discuss it next week, okay? But I find that if I just tell you the shortcut, a lot of people don't actually figure out what's going on, and they do it a couple of times and then forget the shortcut, and then they're stuck because they never actually learn how to do it. So what I want you to do is multiply these out. When I do the distributive property here, 6 times 6 is 36. 6 times the negative square root of 12 is negative 6 square root of 12, right? The 6 is on the outside, 12 is on the inside. Do the same thing with the next set. 6 times the square root of 12 plus 6 root 12. Root 12 times root 12 minus the square root of 12 times 12. We've got a lot of stuff here that simplifies. Okay, so I went fast there, but all I'm doing is doing 6 times 6 is 36. 6 times the square root of 12. The 6 is on the outside, the 12 is on the inside. 12 times 6, 6 is on the outside, 12 is on the inside. 12 times 12, both of them are on the inside. Now, this simplifies a ton. I have a negative 6 root 12 and a positive 6 root 12. Those cancel out. -6 plus 6 is 0. 0 square roots of 12 is gone. 36 is still 36. The square root of 12 times 12, that's a pair of 12s. That comes out. Minus 12, 36 minus 12 is 28. We're learning this in preparation for what we're going to do next week. This is how you get rid of square roots when you have a binomial pair. If you have a square root and something else, or two square roots, but they're different, you can't combine them. This is how you can get rid of them. Notice our answer is just a whole number. Yes. It is. Thank you for, again, going too fast here, going off of what I was remembering from last period. That is 24, not 28. Thank you for catching that, Alyssa. So real fast, last example here, and then you'll have a few minutes to do some homework problems. Look at letter C. Skip letter B. It's exactly the same as what we just did. Look at letter C. 5 times 5 is 25. 5 times 2 root 3. 5 times 2 is 10 root 3, right? The numbers on the outside get multiplied together. The numbers on the inside get multiplied together. So in this case, it was just 5 times 2 is 10. Here, -2 root 3 times 5 is -10 root 3. And then right here, this is where people often make mistakes. -2 root 3 times 2 root 3. -2 times 2 is -4. Root 3 times root 3 is the square root of 3 times 3. Once again, I have middle terms that cancel out. 10 root 3 minus 10 root 3 is 0. I have 25 minus 4. Square root of 3 times 3, that's a pair of 3s. Those come out. 4 times 3. 4 times 3 is 12. 25 minus 12 is 13. If I did it right this time. Notice again, this right here is where people make mistakes. The outside numbers get multiplied together. The inside numbers get multiplied together. The inside numbers come out, but there's only one of them there. So 4 times 3 makes the 12. Subtract, there's our answer. So the homework tonight is 1 through 10 all, and then 12 through 26. So you've got a total of like 17 questions. The hope is you've done at least half of them at this point. I would suggest that you guys try on the homework right now. Try number 22 at least. Try number 22 at least. Check with your group. Make sure you all get the same thing. I am going to collect sections 1, 2, and 3 on Monday. Okay? 1, 2, and 3 on Monday. That gives you today, Saturday, Sunday to get everything caught up. We'll be a third of the way through the unit at that point. You'll turn in those 3 sections. I'll check them off. I'll get them back to you. So again, homework 1 through 10 all, 12 through 26 even. That is on Google Classroom if you need to check it. You try a couple of variables? Any of them? Again, we did 18 and 20 together, but you got those. You got first part, not part. So then you get the notes, those for the variable part. Okay. No questions about it? How about you all, Hunter? Making sense? Okay, I understand. Too bad. Once you still an hour off, hopefully you can hang in there. It is fun. So you still have 3 or 4 minutes here. If you want to get a couple problems done, I would recommend it. If not, just make sure they get done by Monday. Yes, I'm gonna what? sections 1, 2, and 3 on it. And I did post those on the Google Classroom. And check, so I got all the problems done. That's listed there too. Yeah.